metal oxide semiconductor. So if you can remember this name, metal oxide semiconductor. So you can easily draw the construction of MOSFET. So these MOSFETs are also called as, these are also called as insulated, these are also called as IGFET, these are also called as IGFET. So insulated gate, insulated gate, FET. So why it is called insulated gate means it can be derived from the name itself that the metal gate, I'll write here, the metal gate is insulated by an oxide layer. So gate and channel are separated by an insulating material called the oxide layer. So that is why here we call it as insulated gate. So gate is insulated by a thin layer of oxide. The semiconductor channel and gate are both separated by oxide layer which acts as an insulator. That is why it is called as insulated gate. Gate is separated from the channel. So these MOSFETs are widely used in ICs, integrated circuits, due to its relatively smaller size. Due to the relatively small size, thousands of these devices can be fabricated in a single integrated circuit. Okay, the speciality is that relatively small size of MOSFETs, thousands of MOSFETs are integrated or fabricated in a single IC. So generally the area occupied by this MOSFETs, it is 5% the area occupied by 5% of area required 5% of area required for BJT. So 5% of the area required for whatever the area BJT occupies, out of which only 5% is the area required for this MOSFETs. That is why in the integrated circuit technology, thousands of MOSFETs are fabricated. So this is one added feature, and another one is that very high input impedance in the order of 10 power 10 to 10 power 15. High input impedance in the order of 10 power 10 to 10 power 15 ohms. Input impedance of BJT is very low. So compared with BJT, input impedance of FET is high. Compared with FET, input impedance of MOSFET is very high. So input impedance is very very high. So there are two types of MOSFETs. So these are the two important features of MOSFETs. So MOSFETs are two types. Enhancement, enhancement MOSFET, depletion MOSFET. So this is also called as E MOSFET. In short form, we will write as E MOSFET. And it is DE MOSFET, depletion MOSFET. So you can easily remember depletion, enhancement. So the meaning is that in both the cases, in FETs, I'll write here, in MOSFETs, the controlling voltage will be VGS only. ID is mainly controlled by VGS, the gate voltage. That is gate voltage. Like in FET, here also gate voltage will control the drain current. So therefore, here in enhancement, the gate voltage you can write that applying gate voltage enhance and the name is that enhance. So applying gate voltage it increases the number of charge carriers, increases the number of charge carriers for conduction. It increases the number of charge carriers for conduction. అందుకే enhance అని అన్నాము conduction. So here applying gate voltage, here the number of majority carriers, the number of majority carriers which are available for conduction are reduced. Here the reverse happens. Number of majority carriers number of majority charge carriers available for conduction are reduced. regulated. So that is why it is called depletion. Depleted. Depleted of mobile charge carriers means reduced, removed. So here the number of charge carriers increases the number of charge carriers per conduction, whereas the number of charge carriers which are present initially are reduced. Are reduced. That is why the name depletion MOSFET. So the basic initially I am telling you the basic differences, so which we'll encounter when we discuss the working. And another difference is that the basic differences I'm writing. Another difference. Channel does not exist. Channel is not. Channel is not existing. Channel is not created while construction. మనకి ఛానల్ ఏమి ఉండదు మనం కన్స్ట్రక్ట్ చేసేటప్పుడు అసలు ఛానల్ ఏం క్రియేట్ చేయం వైల్ కన్స్ట్రక్షన్ whereas here channel will be there. channel is channel is formed. Channel is created at the time of construction. So initially, while fabrication itself, the channel will be diffused in depletion MOSFET, whereas in enhancement MOSFET, channel will not be there. But later later during its operation, channel is formed internally. A channel is formed. అదే ఇక్కడ అనుకోండి ఛానల్ ముందే క్రియేట్ చేసి పెట్టాం కన్స్ట్రక్షన్. And a note which is common for both MOSFETs is that no PN junctions. Here there are no PN junctions. No PN junctions. No PN junctions are formed between gate and channel. Gate and channel. అసలు మాస్ఫెట్ లో ఏంటి గేట్ కి ఛానల్ కి కనెక్షన్ ఉండదు. గేట్ ఛానల్ విల్ బి సెపరేటెడ్ బై అన్ ఇన్సులేటింగ్ మెటీరియల్. సో నో పిఎన్ జంక్షన్స్ ఆర్ ఫార్మ్డ్ బిట్వీన్ గేట్ అండ్ ఛానల్. So no junctions are formed between gate and channel. So whereas the gate is separated by the channel with an insulating material. అందుకని మనకేంటి అసలు గేట్ కరెంట్ జీరో ఉంటుంది. గేట్ కరెంట్ ఐజీ ఇస్ ఎగ్జాక్ట్లీ జీరో. అదే ఫెట్లో అయితే ఏంటి, ఫెట్లో ఇన్ ఎఫ్ఈటి గేట్కి ఛానల్కి మధ్యలో పిఎన్ జంక్షన్స్ ఫామ్ అవుతాయి. గేట్ అండ్ ఛానల్, టూ పిఎన్ జంక్షన్స్ ఆర్ ఫార్మ్డ్ between gate and channel and which are reverse biased. So, though we are saying that Ig is ideally zero, but practically there is small reverse saturation gate current will be flowing in FET. But here in this case of MOSFET, అసలు గేట్కి ఛానల్కి సంబంధమే ఉండదు కాబట్టి గేట్ కరెంట్ జీరో. ఐసోలేట్ చేసుకుంటాం గేట్ని, ఛానల్ని ఒక డైఎలక్ట్రిక్ మెటీరియల్ ఇన్సులేటర్తో ఐసోలేట్ చేస్తాం కాబట్టి అసలు గేట్లో కరెంట్ అవుతుంది. దట్ ఇస్ అనదర్ డిఫరెన్స్ బిట్వీన్ JFET and MOSFET. So because of this, the input impedance is very, very high. So now we will see the construction. We will see the construction of MOSFET. So we will take first we take a semiconductor bar. So whether it is E MOSFET or DE MOSFET, two types, N channel E MOSFET ఉంటుంది, P channel E MOSFET. So ఇక్కడ దీన్ని రెండులో మళ్ళీ two types. Again further classified into two types, N channel and P channel. N channel and P channel. So ఇక్కడ కూడా N channel D MOSFET, P channel D MOSFET. So we will take, let us say, N channel. One second. So now we will take N channel E MOSFET. So for N channel E MOSFET, we will take a base material or body material which will be the support for the device. So that material we will call it as the substrate. This is also called a substrate or body. This is called the substrate or the body which will give you the support for the device. So in N channel, the substrate is going to be P-type. In N channel, we will take a substrate, P-type substrate, P substrate. We will take a P-type material, we will take a substrate, P-type substrate. And the substrate is nothing but a single silicon wafer on which the MOSFETs are fabricated. So this it is fabricated on a body or the silicon wafer, which is nothing but the substrate. This is also called as the body. So in N channel, the substrate must be p-type. So into this substrate, we will diffuse two heavily doped. We will diffuse two heavily doped N plus regions. So N plus N plus. Now so over the surface of the substrate. Now we will deposit, will grow a thin layer of SiO2, silicon dioxide. Over this, first we'll take a p-type substrate, and into the p-type substrate, two heavily doped N plus regions are diffused. And once this is done, over this substrate, a thin layer of dielectric material or insulating material is deposited. A thin layer of dielectric material is deposited. So this is oxide layer. Oxide layer, it acts as dielectric. Acts as dielectric or insulating material. Insulating material. Now, what we will do? So these two N plus regions acts as source and drain. So one N plus region acts as source and the other N plus region acts as drain. So but there is no contact. We cannot access the source and drain. Therefore, to make contacts for the source and drain, to make contact for the source and drain, so holes are cut. Holes are cut. Holes are cut. So these are holes are cut into this oxide layer, and a metal is deposited. So this is a metal. So like this. So a metal is deposited. Holes are cut into the oxide layer, and the metal is deposited into the holes. So with this metal contact, we can make a contact. Now we can provide a contact for this N plus region, and that we are calling it a source. And here also holes are cut holes are cut into the oxide layer, and the metal is deposited. And the metal is deposited so that contacts are made for the two N plus regions. One will be acting as source and the other will be acting as drain. This is drain. And here, so this is the the region between the source and drain. The region between the source and drain is again covered by depositing the metal. So here also we will be depositing metal. So a layer of aluminum metal is overlaid. This is aluminum metal. It is overlaid on the surface of oxide layer, which exactly which exactly cover the channel region. So this is called the channel region, but there is no channel is established. We are saying that N channel. We are saying that channel N channel Mosfet. But to look at, there is no N type channel existing between source and drain. Okay, so there is no channel present in the enhancement MOSFET, but the region which is existing between the source and the drain. So whatever the metal we are going to deposit here, that will cover the region between source and the drain. Now here again one more contact is made. This is called a gate. This is called gate. Now if you look at, this is the construction of enhancement MOSFET. This is the construction of enhancement MOSFET. Now we will see the working of enhancement MOSFET. All of you see here. If there is no voltage, if there is no voltage on gate, no. So before we move on to the construction, I will give you a note related to the substrate. So always in N channel. So here the substrate is connected. The substrate is to be connected to the most is connected to the more negative potential. So N channel అయితే P type substrate కి P type substrate ని ఎలా కనెక్ట్ చేయాలి అంటే ఎంత నెగిటివ్ పొటెన్షియల్కి కనెక్ట్ చేస్తే అంత ద మ్యాక్సిమం నెగిటివ్ పొటెన్షియల్ వీ నీడ్ టు కనెక్ట్. ఎందుకంటే ఇక్కడ చూడండి. సో ఎన్ పిఎన్ జంక్షన్ is there. This is n source and this is p type substrate. P type substrate. So suppose source is VGS అంటే this is source, if this is gate. So gate దగ్గర suppose 2 volts అనుకోండి. If it is 2 volts, then gate will be at 2 volts and source will be at 0 volts. So 2 0. So VGS 0 means what? VGS equal to 2 volts means VG is at 2 volts whereas Vs is at 0 volts. So ఇప్పుడు చూడండి, the n type source is at 0 and p type we need to give to the more negative potential. ఎందుకంటే the fact, the reason you need to remember is that the junctions which are existing between the n plus and substrate. So junction is existing between this n plus sources, source, drain and substrate. So here one junction is there, here one junction is there. Okay. So always drain current should result when the charge carriers are moving from source to drain. When the charge carriers are moving from source to drain. So the charge carrier should not move like this from source to substrate. So source నుంచి సబ్స్ట్రేట్కి మూవ్ అవ్వకూడదు అంటే సోర్స్ సబ్స్ట్రేట్ లేదా సోర్స్ డ్రైన్ సబ్స్ట్రేట్ జంక్షన్ని ఏ బయాసింగ్లో ఇవ్వాలి? ఎవరైనా చెప్పగలుగుతారా? దేర్ షుడ్ నాట్ బి నో ఫ్లో ఆఫ్ చార్జ్ క్యారియర్స్ ఫ్రమ్ సోర్స్ టు సబ్స్ట్రేట్. దేర్ షుడ్ బి ఫ్లో ఆఫ్ చార్జ్ క్యారియర్స్ ఓన్లీ ఫ్రమ్ సోర్స్ టు డ్రైన్. అప్పుడు మనకు డ్రైన్ కరెంట్ అంటాం. సో ఆల్వేస్ దిస్ ఎన్ ప్లస్ అండ్ పి junctions, n plus and p junctions are always reverse biased. Are always reverse biased. n plus and p junctions are always reverse biased. అందుకని మనం ఏం చేస్తాం జనరల్గా ఈ పీకి the substrate p will be given the potential such that this n plus and substrate junctions, whatever junctions are formed between these n plus regions and substrate, they are always reverse biased. So reverse bias ante the leakage current is almost zero. So there is no current in this direction. There is no current in this direction. So only current will flow from source to drain. There is no current from source to substrate or substrate to source. So that is why P-type substrate always must be connected to the negative potential in N channel. So N channel lo P-type substrate is to be connected to the more negative potential or negative potential. Okay. So now we see the construction. So initially you need to observe that there is no channel is existing between source and the drain. This substrate is just supporting material or silicon wafer over which this Mosfet is constructed. So there should be physically some channel. There should be physically some n-type material, n-type channel must exist. It should exist between source and the drain, so that as soon as you give some drain potential, as soon as you give some potential at the drain, as soon as you give some potential at the drain like 2 volts or 3 volts, then the charge carriers will start flowing from source to drain. But there is no channel at all. So there is no channel at all. If there is a channel, then to provide VDS, the charge carriers will start moving through the channel from source to drain. But if a channel is laid, so first the channel must be established. ఇక్కడ చూడండి. So how to establish the channel is, yes, we have given some VGS. Alright, VGS is 0, VDS is 0. So గేట్ దగ్గర వోల్టేజ్ లేదు, డ్రైన్ దగ్గర లేదు, అంటే డ్రైన్ కరెంట్ ఐడి is 0. No channel is established. No channel is established. So let us say VGS will give some positive voltage on gate, will give some positive voltage. If I give a positive voltage on gate, so because of this positive voltage, because of this positive voltage, because of this positive voltage, whatever the holes are there, whatever holes are there, whatever holes are there in the P-type substrate, they will get repelled. They will get repelled by the positive potential on gate. They will get repelled by the positive potential on gate. So they will get repelled by the positive potential on gate. So when these holes are moving, when these holes are getting repelled, that is when they are moving away from the oxide layer, when they are moving away from the oxide layer, it leaves a negative ion. It leaves a negative ion behind its position. Behind its position. So when holes are leaving, the acceptor atom acquires a negative ion, and the holes are leaving. Yes, how hole will disappear when the acceptor atom gains an electron? Then that electron will occupy the place of a hole. So when an atom acquires an electron, it gets negative ion. It acquires negative charge. So the negative ions are created. So when holes are getting repelled, and the holes are moving away from the oxide layer, when they are moving from this oxide layer, then negative ions are created, and after some time, even if this gate voltage is further increased, one second. So when holes are getting repelled, they will leave a negative ion behind its initial position, and if gate voltage is further increased, then whatever electrons will be moving towards the oxide layer, and holes will be moving away from the oxide layer. So these electrons and ions are also negatively charged, and electrons are also negatively charged particles. So an n-type an n-type channel is said to be established. An n-type channel is said to is said to be established, is said to be established in the which is extending from source to drain. A region of n negative charge carriers, a region of negatively charged ions and charge carriers is established uh, below the oxide layer, which is extending from source to drain. So is called this is the channel which has formed when a sufficient positive voltage is applied on the gate. So now if you give some drain voltage, this electrons from source, they will move through this n-type channel, and they will be reaching the drain. So like this, some drain current is going to be established in the E MOSFET. So it is called enhancement MOSFET because the channel which is not there at the time of construction, it was established. And this channel is also called as inversion layer. It is also called as inversion layer. So why it is called inversion layer means in the p-type substrate, n-type channel is created. So the substrate is p-type, but the channel which was established is of opposite type, okay, n-type. And it is an inversion layer. So the the voltage required on the gate to establish the channel is called as the threshold voltage. To establish the channel is called as threshold voltage. So the E MOSFET, the enhancement MOSFET, it, it means as soon as you give some positive voltage on the gate, drain current will not exist in the MOSFET. The drain current will exist. Drain current ID exists in E MOSFET. ID exists in E MOSFET only when VGS is greater than or equal to VT. So when the gate voltage greater than or equal to the threshold voltage, then only the channel will be established when the charge carrier starts flowing from source to drain. Therefore, we say that in general we say that for VGS equal to 0, for VGS equal to 0, E MOSFET is said to be normally off. Why E MOSFET is said to be normally off? 2 marks question array. Said to be normally off. Why E MOSFET is said to be normally off? Because when VGS equal to 0, there is no channel established below the oxide layer, which is extending from source to drain. Therefore, no charge barrier will move from source to drain, and therefore the current is 0. Therefore, E MOSFET are said to be normally off MOSFET. They are said to be normally off. So this is the reason why they are normally off. So to turn on the E MOSFET, the voltage required on the gate should be minimum threshold voltage. The minimum voltage required to turn on E MOSFET is the threshold voltage. So this threshold voltage value depends on the fabrication technology. The value of the threshold voltage depends on the fabrication technology. Fabrication technology of the fabrication technology used depends on the technology used for the fabrication. So as soon as when VGS exceeds VTH, when VGS is greater than or equal to VTH, channel is established, and as soon as you give some drain source voltage, ID current starts flowing through the channel. సో మీరు VDS ఎంత ఇచ్చినా కూడా ఛానల్ ఎస్టాబ్లిష్ కాకపోతే కరెంట్ జీరో ఉంటుంది. అందుకని VGS జీరో ఉంటే నార్మల్లీ ఆఫ్ అంటారు. సో ఈవెన్ ఇఫ్ యూ ఈవెన్ ఇఫ్ దెర్ ఇస్ నో ఛానల్, ఈవెన్ దిస్ VDS is 5, even if you apply some positive voltage on the drain, ఇక్కడ ఎంత హై వోల్టేజ్ ఇచ్చినా అసలు ఛానల్ లేకపోతే, if there is no channel, then there is no current. So once a channel is established, as soon as you start increasing this VDS, current starts flowing through the MOSFET. So why it is called enhanced means, initially there was no channel, but during its operation with the sufficient positive voltage on the gate, the channel has been established. So that is why it is called enhancement mode. So that is why it is called enhancement mode. So the VI characteristics of MOSFET. We'll see the VI characteristics of the MOSFET tomorrow. Is it okay? Or shall I continue? You said we had some activity. I did. Shall I continue? Or shall I end? ఓకే, మీరు రెండు అనే వరకు నేను చెప్తాను. సో we'll write here. ID is going to be 0 only. When this Good. Channel is established. Channel is established, and as VDS is increased, as VDS is increased from 0, once channel is established, as we start increasing VDS from 0, ID starts flowing through the device. ID starts flowing through the device. If VGS is if VGS becomes more and more positive, what will happen if the gate voltage is increased further beyond threshold, if we increase the gate voltage further, more number of electrons will be induced into the channel. The more number of electrons will be entering into the channel. So as gate potential is increased, more and more negative charge carriers are induced into the channel. So these induced charge carriers, electrons, these are the induced charge carriers which are coming from the substrate, and these charge carriers will get attracted towards the drain connect which is given positive potential. So like that, the charge carriers will move from source to drain. So as more the gate voltage is, more number of electrons will get attracted, and more number of electrons will be induced, and more number of electrons will be moving from source to drain. So drain current increases with VGS. The drain current is mainly controlled by gate, the voltage on the gate. So here the channel conductivity is increased when more positive voltage is applied on the gate. Therefore, we say that the channel conductivity has enhanced. Communicating enhancement mode ಅನ್ನೋದು. In the next class, we'll see the depletion mode, and together we will draw the VI characteristics of depletion and enhancement mode at the same plot. Ajay, will you send me the attendance?
Yes, madam.
Okay then. You can continue with your research activity. Okay, then you can leave.
Okay, madam.
Tomorrow we will finish up the VI characteristics of the enhancement Mosfet as well as depletion Mosfet. So once I finish up the enhancement and depletion Mosfet,